Hey class! We're going to be looking at the volume of pyramids and cones today. Check out those pyramids. Our objective today will be to learn and apply the formulas for both the volume of a pyramid and the volume of a cone. So the volume of a pyramid is related to the volume of the prism with the same base and height. So take a look at that bottom cube. That is a cube. It's a prism. This particular one happens to be a square. So, well, a square prism. So it is a cube. And then each one of those, the purple, the green, and the yellow, are all dividing that cube into three congruent square pyramids. They're congruent because they all have the same base and they all have the same height. So the square pyramids are congruent, so they have this, since they're congruent, they're going to have the same volume. And the volume is always going to be found as 1/3, right? One volume is equal to 1/3 of the base times the height. So here we're going to find the volume of a rectangular pyramid, and it has the length, the width, and the height given to us. Now the base will be the length times the width. So that's going to be 11 times 18. And then the height is 23. So we can say that the volume then is going to be 1/3 of the base, which we know is going to be 11 times 13. And that's going to be multiplied to the height, which is 23. We can do this in all one thing in our calculators, and we're going to get 1,518. And don't forget our unit, which is meters. It will be meters cubed. So here's another example where we're finding the volume of a pyramid. This is a square pyramid, so our base is going to be side squared. Right? The base edge is 9 centimeters. So if we're looking at the volume of this, we're going to take 1/3 of the base, which is 9 squared. And we have a height of 14, so we're going to take that and multiply it to 14. When we put that into our calculator, we're going to get the nice number of 378. And let's not forget our unit, which is centimeters. And because it's volume, it is cubed. On this example, we have an art gallery, and it's a 6-story square pyramid with a base of area that's a 1/2 acre. So, and that gives us some conversion things. So we're going to estimate the cubic yards, the volume in cubic yards and cubic feet. So let's start with the first thing we want to do. Well, we know the base is a square with an area of about, and it's going to be half of this. So the base has an area of about 22,420 square yards. And since it is a square, that means that that's equal to the sides squared. So if I take the square root of each side, the base edge length is about 49 yards. Now the height is 6 stories. So, 6. And a story is about 10 feet, so we're going to multiply that by 10. So our height is going to be 60 feet. So we want to do this first in yards. So everything has to be in yards. This is already in yards. 60 feet has to be given to us in yards. So 60 feet, and if we divide that by 3, that's going to be 20 yards. So we're going to take 1/3 times 49 squared times 20. Oops, I forgot that. And that's going to give us 16,100 cubic yards. Then we want to convert our answer to find the volume in cubic feet. The volume of 1 cubic yard cubed is 3 feet by 3 feet by 3 feet, or 27 feet cubed. So our conversion factor is going to be 27 feet cubed over 1 yard cubed. So if we multiply this answer to our conversion factor, then instead of having yards, we're going to have it in feet, and we take 16,100, multiply it to 27, and we're going to get 436,000 feet cubed, or cubic feet. The volume of a cone has the same formula as the volume of a pyramid. It's 1/3 base times height. Now the base of the cone, though, is a circle, so the base is pi r squared. So our formula is 1/3 pi r squared times the height. So let's find the volume of a cone. This one has a radius of 7 and a height of 15. So, and we're going to give it in terms of pi and then round it to the nearest tenth. So our volume is going to be 1/3 pi times r squared times the height. Now 1/3 times 7 squared times 15 is going to give us 245 pi centimeters cubed. So that's in terms of pi. And if I want to get an approximation, and I'll round this to the nearest tenth, I'll take 245 and multiply it by pi, and I'm going to get 69.7 cubic centimeters. In this example, they didn't quite give us the exact information we need, but we have enough information to derive that. It tells us that the volume, we want to find the volume of a cone with a base circumference of 25 pi inches and a height of 2. So we do know the height is 2. But the circumference is 25 pi. And we find the circumference by 2 times pi times r. So if I use this to determine what my radius is, so if I divide by 2 pi on each side of this equation, I'm going to get r is equal to 12.5. So now I have the information I need. So I am going to find the volume of 1/3 times pi r squared, so 12.5 squared times 2. So in terms of pi, that would be 1,406.25 pi, and our unit is going to be inches cubed, which is approximately, as a decimal, when we multiply the pi to that number, we're going to have 4,417.9 inches cubed. On this cone, they gave us the radius, but they didn't give us the height. So we know the radius is 16, but the height is this length right here. They gave us this slant height of 34. But notice that this creates a right triangle, so we can use Pythagorean theorem to find the height. It would be the height squared plus 16 squared is equal to 34 squared. So 34 squared minus 16 squared is going to be 900. And so that if you take the square root of each side one, the h, or the height, is going to be 30. Now that I have the radius and the height, I can find the volume. The volume is 1/3. Oops, that's not a 3, that's 2. Sorry about that. 1/3 pi times r, which is 16, and we'll square that, times the height, which is 30. So that's going to equal 2,560 pi, and that is in centimeters cubed, which is approximately 8,042.5 centimeters cubed. Now we're going to find the volume of a composite three-dimensional figure. If you take a look at this figure, we actually have three things that we're going to find. We have an upper cone, and we have a cylinder, and we have a lower cone. So we will find those separately and then add them all together. Let's start with this upper cone. This upper cone has a radius of 21. And it has a height. Well, it doesn't tell us this height, but we know that from this tip to the bottom of the cylinder is 70, and that the cylinder is 35. So the height is going to be 70 minus 35, which is 35. So now we know that the height is 35. So the upper cone is going to have a volume of 1/3 times pi times the radius squared times 35, the height. And what that gives us, and let's keep these all in terms of pi, 5,145 pi. These are in centimeters cubed. All right, so we're going to just save that one, and let's find the cylinder and the lower cone. So we found the upper cone. Let's find the cylinder next. The cylinder is going to be the base times the height. So the base is going to be the circle, and our r is 21. So it's going to be pi times 21 squared, and it's going to be times the height, which we found is 35. So that gives us a volume of 15,435 pi centimeters cubed. So we're going to use this one, we're going to use this one, and now we need the lower cone. And that volume will be 1/3 pi r squared. R is once again 21. And times this height happens to be 40. So this comes out to be 5,880 pi centimeters cubed. So we're going to add up these three volumes. So 5,145, 15,435, and 5,880, and that's going to give us 26,460 pi centimeters cubed. And then if we want a decimal approximation, we multiply that number by the value of pi. We get 83,126.5 centimeters cubed for that whole figure.